In this case, the instructions told you that you had two separate terms of a geometric sequence. You have to be told that you have geometric or arithmetic in order to know which formulas to use. If you're not told and you're only given this info, it's kind of tough to figure that out. This was geometric, so you're going to use your a sub n, this first term, r to the n minus 1. And you use that for both of them. So what you're going to do for this one is you're going to do a system of equations, but the system of equations works out to be via substitution as opposed to elimination method, what we did with arithmetic. So you substitute in. Second term is first term rate to the 2 minus 1, so negative 20. First term rate to the first power. Fourth term is first term rate to the 4 minus 1, so negative 5 is your rate, or your first term rate cubed. When you're dealing with these things, it's always easier to rewrite it in terms of the first term, a sub 1. Always write the one that has the lesser degree for the rate into that other term because it'll be easier to simplify later. So negative 20 over the first term, excuse me, is your rate. Oh, I'm sorry, I did that backwards. I just said the wrong thing. Substitute into the other equation. Negative 5 is negative 20 r cubed. So you wind up with 1/4 is r squared. So r is 1/2. There's your rate. Substitute back in for into your r value. Here, you get negative 20 divided by 1/2, which is negative 40. Is your first term. So your rule is a sub n negative 40 times the rate of 1/2 to the n minus 1.
Is it 1/4 or 4?
It's negative 5 divided by negative 20.
But it's 20r cubed, that exponent's 20r.
Or 20r squared.
Oh, okay.
You divide by the negative 20.
I like moving it down.
Careful. Okay. What?
Also so then you said arithmetic use elimination and
Yeah.
geometric.
Substitution. Because it's really nice with the arithmetic ones because it's got that plus sign in between, so you're going to be able to eliminate that first term and solve for your common difference, whereas this one you're solving for the common rate by using substitution. Okay. Does that help out? That's good. Yeah. Couple things then about as far as the test is concerned. There is 2 parts, matching and everything else. That's why I have a degree in math. What?
I forget what you said. You said you have the matching, and then when you get the other.
I'm getting there. How many formulas do we have?
5.
5. So you had arithmetic. Sequence, and then series, geometric sequence, geometric series, and then we have the infinite geo. So you only had 5 formulas. And when you look at them, remember arithmetic, when you had the common difference, so it's first term, n minus 1 times the difference. The geometric was different. It had the rate. Pay attention up here, not to hint. Might be helpful for you. And then going through the series ones as well. Yes, sir.
Is there a particular reason why we don't have like a arithmetic infinite sequence?
Yeah, because when you have the, well, how does it work out? When you're adding stuff constantly, what's your sum going to be?
It's just going to be infinite, right?
Right.
So you can't solve for the
Correct. And the reason why you have the geometric infinite is that if you look at the geometric sequence formula, It's exponential growth, exponential decay.
Okay.
And exponential growth, exponential decay are approaching a specific value. That's why we have that.
Okay.
All right, that's a good question. Yes, ma'am.
Can you go over when you would use the phrase?
You have to know. It has to tell you when you.
It'll tell you when not to use it.
Yeah, it'll say such and such is a thing and you use this.
In every single place.
Pretty much. It's not like you're gonna be given a set of numbers and write the rule. Like alphabetical.
But like we would use them, if you did it
I bet.
where there was the sigma and then.
Let me finish off by writing out the rules and I'll show you a couple of things here and there. Yes, sir.
Are we gonna want the infinite geometric series, how it is, when it explained it? We were talking about that yesterday.
Oh, why do you think I'm
Yeah.
getting there?
Okay.
The arithmetic series, the sum of an arithmetic, that is when you have this certain amount of terms, first term, last term, over 2. The geometric one was the weird looking one. That was first term. It was first term. No, it wasn't. It was first term, thank you. Oh, then it was 1 minus, yeah, for some reason I blanked. 1 minus r to the n, 1 minus r. And the reason why the geometric infinite series looks the way it does is that as n is growing larger and larger and larger, remember, your rate itself, excuse me, your rate itself is between, it's got an absolute value of 1, or less than 1, excuse me. So as the n value grows larger and larger, you start approaching where when you take 1 minus your r value, it's approaching to become 1. Okay? It's approaching 1. That's why the infinite one is just your first term over 1 minus r. Because as this gets larger and larger and larger, it approaches 1. That's all it is. So that's why it's just an S. Oops. Also notice that the infinite one is just an S. If you think of it as an S, it's kind of half an infinity symbol. It's like half of an infinity symbol.
Yeah, that's
More than 2/3.
Just squint.
I can't see anything. Looks like
Sorry, pink guy, yeah, shut up. Now, what happens then is, can you identify what will be is a list of formulas, which one is which? It's kind of how it works out. When it comes to the test portion then, I will have all of them written down. You just don't know which one it is, because I'm not going to have them labeled. But at least you'll have the correct formula written down on paper to use. So that way when you're going back and forth, if you memorize it and you accidentally thought that was a subtraction symbol, you know you won't screw it up. Okay? But if you know that that's the arithmetic sequence, you're going to be fine. All right? Is that fair?
Yeah.
Plus, when we get into the final, these are just a couple of formulas that we would put on the final for you anyway. When we get into finals for second semester, we do have specific we have a formula sheet of some things that we'll use. Yes, sir.
So where does that like piece come into play?
That is what it's called sigma notation.
Yeah, when do you do that?
Well, if you wanted to write it out in terms of sigma notation, all it would be, well, let's look at an example. We did more of that in 2, I think.
That's the way you test, right?
Isn't that just calculating?
No, if you want to write it into sigma notation. Otherwise, yes, you're right. You can just go right to the calculator.
Will that be on?
I'm gonna write it out. Was it in this one or was it the other one?
It's 11-1.
Was it 11-1?
Yeah.
Oh, okay. Okay, so if you're talking about series and stuff, you want to write it in terms of summation notation. Whether or not it doesn't really so much matter that it's going to be arithmetic or geometric, it's kind of the same rules. All you're doing is, if you've got, so let's just say it's, if you're going to write in summation notation, it has to be a finite sequence. It's got to stop, or series, excuse me. It's got to be a finite series because there's no dot, dot, dot. So what we do is we draw our E. And the first thing, the easiest thing to do is, how many terms are in this series? 5. So you put 5 up top. Okay. Then you write the rule. Well, what's the rule here? Plus 3, or think of it in terms of 3 times something. 3 times 1, 3 times 2, 3 times 3, 3 times 4, and so on. 3n, yeah. And where n starts at 1. Now there's a couple of ways to do this. You could have said 3n minus 3 where n starts at 2. You could have done a bunch of different ones. You're defining it from there. Does that make sense? Hello?
Where the n equals 1 is where the n stops.
Yeah, where you're defining it at the start. So you could define it if you wanted to start it at 0, and you could have said 3 plus 3n, where n starts at 0. And then you could have said you had 4 terms. Yeah, it would be 0 through 4. That would work too. There's much more.
Are we gonna?
No. I'm kidding.
Are you gonna do what we did?
I'm joking, fella. It's fun to harass.
I did not. Are you gonna, on the test, or is there gonna be like what we did at the beginning where we had to figure out the equation on our own?
Not so much like that. I like to keep it more along the lines
Where we
of,
memorize the equation?
well, not memorize, but can you use it?
Okay. So we don't have to make them our own?
There might be.
Wait, there might be, or there might not be?
For writing something like this and sigma notation?
Oh, and sigma
Yeah.
notation.
Now, what I'm looking at though is, what section was it? It was. You know, when you start looking at review stuff wise, write the rule for the arithmetic sequence. If there's the rule, figure it out. What's the first term, what's the common difference, write it out. So if you're looking at what's your first term? What's your difference? Negative 0.5. So your first term is 3.5, your difference is negative 5, you fill in the blanks. Nth rule, first term, plus, what's that? Oh, I was saying first term at the same time there.
Negative 0.5.
You fill in the blanks. And then you just distribute and simplify. Okay? Combine like terms. Okay. That's how you write those rules through. Like the question you had asked about with geometric, given the 2 terms, you do the exact same thing with arithmetic, then you're worrying about the system of equations with elimination. Works the exact same way, where you'd have to define it out and go. But remember, in this case here, see how it says write the rule for the nth term of the arithmetic? You have to be told it's going to be arithmetic if you only are given a certain amount of information. Okay? If you're given 2 terms in a sequence, you've got to know that it's arithmetic, otherwise it won't work. So those are your 2 terms for an arithmetic sequence. You write out the rule and you fill in the blanks. Well, your nth term, your fourth term is the first term, 4 minus 1 times the common difference. Well, that means 20 is first term plus 3 times d. And I do the same thing for the 13th. The 13th term is 65, which is going to be first term plus 13 minus 1 times the difference. And then you're at your system of equations. And you subtract them out. Okay. That's how you're able to eliminate out that first term, to isolate it out. And then write the rule.
So it doesn't matter where you put the 5 or the year, you can do it in that movie or the
Correct.
school.
Yeah, correct. Doesn't matter. Either one works.
You can do it that way.
Either one, it's fine. Is that what you think? Yeah.
Where's the
It eliminated. I subtracted.
Oh,
It's a simple equation. Subtracted the top from the bottom.
I didn't see you take that over.
Or, I'm sorry, bottom from the top, excuse me. Yeah, no, we got it.
Clarification, when you give an answer, like when you write down the equations, but only on certain things where you wouldn't FOIL it or multiply out is when it's exponents.
Yeah. Yeah, because that's going to be to the n minus 1. Because you'll have your first term and your rate. What I was telling third hour is that I did have, I mean, at one point in time, obviously it worked out weird with the timing for this stuff with the conferences, and then next week we'd do that park stuff, is that we would normally spend about the next 2.5 days dealing with what's called a recursive rule. We don't have 2.5 days because it just spent out over the longer weekend again, and then you guys would be messed up for park testing, then you guys would have messed up because of Humanities 3 testing, and it just would have been a nightmare. So we're not going to bother with that now. We'll worry about that when we come back through. So when you go back online, what I put on here in the chapter 11 stuff is that I have a tab here of the review-ish things. The problems themselves are basically the exact same, well, they are the exact same thing that we've been doing, except that they're written ever so slightly different. There's something called an explicit rule and a recursive rule. Explicit rule is what we've been doing, the explicit formula. Write the rule for the nth term. That's all that means. Later on, we talk about recursive. They just call it something different, even though it means the same thing. It's just a fancier way of writing it. That's all these things are. Some of these, this first page, are you have to define the sequence and go from there. That might be a little bit more than what we've ever done, so I wouldn't even bother with that to start out. I'd go figure out the arithmetic sequence. There's your number of 8. You want evaluate it. Oh, sorry, series, excuse me. 6, 9, 12, 15. You'd have to, bless you. What's the first term? What's the common difference? You want to find the sum of 8 of them. You know how to do all that. It's just using the formula. Determine the number of items in the series. Well, first term is -3, the difference is 8. You want to find the sum of them that add up to equal 1725. You use the series formula and you substitute in the values. Okay. Same deal with geometric, same deal with the geometric series. Remember, that's when with the geometric series you're trying to find solve for n, that's when you use the logarithm. When the arithmetic series, when you're solving for n, you wind up with a quadratic, but you just use y equals and you find the positive value. Okay? So you got the calculator that it does the work for you, so it makes your life easier. Yay! Alright. Infinite series. You can find the sum of an infinite series if you know the first term and the rate. You can only solve it if the rate has absolute value of less than 1, less than 1, less than 1. Okay? So all of this is there. Two terms geometric sequence with the ratio, find the ratio, write the formula. Here's the specific term in a geometric sequence, there's the rate, write the formula. Again, don't worry about recursive, it's not a big deal, we haven't taught it yet. All the way through. And there was no reason for me to spit out 6 pages in review when you can go online and it's all right there and all the answers are there. Okay? Everything's right there. Very simple stuff. You know, PDF it, put it on your home screen, you can look at it right there.
I tend to think that this is probably one of the easiest things that we do second semester. I really do. Yes, ma'am.
Are you gonna, like, on a test say explicit and recursive?
No, because write the rule for the nth term. That's what it says. Write the rule for the nth term. All right, like I was just saying, you don't know that terminology stuff yet. Okay. Let's see.
That picture's so bad.
Look at her face, it's so.
I know.
All my sports pictures are always bad. Like I had a long jump picture.
What? Did I say something?
Yeah, but like please, Megan, be too serious.
Yeah, right? Both men
What is working? It's on the broken up one. Yeah, it is. Look at it.
What are you trying?
There you go.
So writing harder makes it work better? Wow.
There we go. Put it in the.
It looks like in second grade.
No, don't do it for me, don't do it.
It's not gonna. Was it? All
Oh my god!
Ryan,
right, hold on.
you know how in second
Now put
grade?
it on your wall. Picture, I'd be dead.
Yeah.
Which one?
No, don't, Maddie.
I wasn't in.
What are you doing?
Put the face on the wall.
Yeah.
And on the other.
That's
Yes. Yes.
Yeah, mother.
I want to see.
Okay, that's better.
Which one's the real Bell?
I'm awesome at
The
Photoshop.
real bell.
Which version is the real 14?
You should see Brandon in Photoshop. It's amazing.
Friends, yes.
Where do I get it?
Eric and I in this one picture.
Oh my god.
I don't know. Is there another specific style you want me to walk you through real quick? Yes, ma'am.
Can we do one of like the summation notation with the infinite? Where
Sure.
You have like you have to find A1 and
Yeah.
then, R.
Like one of these?
Yeah, no, one of those. Yeah.
Okay. Find the sum of the infinite geometric series given in summation notation. So if you're in summation notation, this is your first term, and that's your rate.
Yeah, I just wanted to.
So all I have to do is the sum, it's going to be your first term, 1 minus your rate.
Sure, Bell. Don't open it. Who is it?
Come back later, do the dishes.
I see that.
And you should get 12. Okay. Same deal on this one. 5 over 1 minus 0.8. So let's see, that'd be 25? 25, I think. That's all it is.
Wait,
Okay.
1 minus
It's 25.
5 divided by 0.2.
Oh,
Yeah, it's 25. That's what I thought. Yeah. Yeah.
It's 25.
Yeah, no.
Is there ever a case where the rate is like hidden, like you have to multiply it?
No, we don't do that. You're really thinking worst case scenario. Because with like trig.
Yeah.
Yeah, nah. That's all good right there. There was one trick on, what was it, 11.4, I believe. No, 3. In 11.3, there is a trick when you're looking at number 63. I'm going to walk you through this real quick. Hold on.
My alarm jumped.
This one gives you a really weird value. This is a geometric series. It told you it was. And it wants you to find the sum of the first 16 terms. So you're looking at a geometric series. And you're doing a lot of substitution. You have to figure out what your rate is. What's going to be your rate? Negative 1/3. So I'm going to find the sum of 16 of them. For the first term of negative 90, I get 1 minus negative 1/3 to the 16. Sorry, I forgot what number I was looking at. And then it's going to be 1 minus negative 1/3. When you're doing a problem like this, you have to be very, very careful in how you set them up. Okay? When you put it in your calculator,
Sorry.
should be. So in your calculator, just do bits here, okay? Take the numerator, figure out that, divide it by parentheses the denominator, then multiply it off by negative 90. So I would type in 1 minus parentheses, alpha y equals negative 1/3 parentheses to the 16. That gives me some crummy number. Oh, that didn't work. I forgot to close the parentheses, didn't I?
No, that's what I got. And I closed the parentheses.
Oh, okay. So this one gives you your numerator. Divide that by. Is everybody okay that that's going to be 4/3? Yeah. So I just divide that by parentheses 4/3. I get some other crummy number. I take that crummy number and I multiply it by
90.
and I get a less crummy number. 67.5. Negative, thank you. So the sum of 16 of them would be negative 67.5. Now, the other one, they're trying to find the sum of them where it equals negative 66 2/3. Put everything into a fraction. Negative 66 2/3 is negative 200 over 3. So you have negative 200 over 3 is going to equal your first term times the quantity 1 minus your rate to the n over 1 minus your rate. You okay with that? Remember, this denominator here equaled 4/3. You okay with that? So what I'm going to do is take negative 90 and divide that by 4/3 just to simplify this portion of the problem. Yeah, though.
Where did you get the negative 200?
From here. Negative 66 2/3. I would convert it to a fraction.
Oh, that's negative 200 over
So if I take negative 90 and I divide that by 4/3, I get 67.5, negative 67.5. Weird.
Wait.
have that. Which means I have to take the negative 200 over 3 and divide it by negative 67.5. And I get another crummy number. You okay with that? This crummy number, this number right now equals 1 minus that. I'm going to move the negative 1/3 to the end, to the left, and take the crummy number to the right. You notice the number here? 9876546.
Everybody's having this realization and then you know. They're talking about
Yes.
7, 8. 8. Put in your calculator, 7, 8, 8.
7, 8, 9, that's one.
7, 8.
You're taking 1 minus that answer, and you get that. It rounds it. It really, I think it's 7, 8, 9, but it just rounds it. How do you undo an exponent? You take a log base of a negative number. No. But what would the exponent have to be with the negative base to give you a positive answer? Even. You get there eventually. Negative, positive, odd. Even. Which way are we going? North. No, we're going east. No, we're going south. No, I bet we're going to go west. Eventually you'll get there. So what happens here, guys, you take the log base of 1/3 because in order for this problem to work, n is going to be even. It has to be even for this to work. So you do log base 1/3 of this answer, whatever that was. So we do our alpha window 5s of 1/3. Guys, come on. Of our previous answer. And there's your result. 4.
Oh, God.
You had to add 4 of them together to get that answer. And if you look at the problem, what's negative 90 plus 30? What's negative 60 minus 10? What's negative 70 plus 3 1/3?
Negative 66. Oh.
Right there.
Oh, that's a cute.
Would we put this show our work if you saw it?
No.
You wouldn't?
You saw it, by all means, go for it.
Wait, how if it asks like, what's the 10th term? Can you just do 1? If you see the pattern, can you do like 1 plus 3 plus 5 plus 7, 10 times?
Be careful, sometimes they do right on the test show all your work for credit.
They? You're the one that makes the tests.
No, I said be very careful, sometimes I write on the
Oh, I
test.
thought you said they right now.
He's referring to himself in the third person.
I'm referring to myself as the multiple person that I am. But yeah, I'm telling you guys, I'm not gonna lie, historically, this chapter test is pretty straightforward. You know, from every variant that I've done throughout the years, you guys tend to do really well on it, so. Look at those review problems, pull ones up off online, and just go from there, and you should be all right. I'll be here in the morning if you got a question here or there, like.